Today we're going to talk about the concept of a limit, but to start off we're just going to talk about functions. The function I want to start with is f of x equals x squared, and I've drawn the graph right here. So far, when you've talked about functions, you've probably talked about a whole function, like looking at the graph, or you've talked about a function at a single point. Okay? So for this one, this point, if we look down, it looks like the x of the point is 2. And it looks like the height, or the y of the point, is probably 4. And a lot of times, you may write it like this, f of 2, which means we want to know when x is 2, what value or height does the function have. And at that point, it has a height of 4. Well, the limit does something different. It allows you to talk about how this function behaves instead of just at one single point. It allows you to talk about how it behaves around a point. So when you think about a limit, we don't actually care what happens at this point. What we care about is around the point, to the left, to the right, all the way around. How is it behaving? So I'm going to actually draw a line right through the point 2. And the reason I'm doing that is just to remind us that we don't want to know what happens at 2. We want to know what's going on around 2, right? All the way around. So how do we figure that out? Well, I usually think of myself as standing on a graph. Okay, standing on the graph. And I'm walking towards that point, the point that we want to know what's going on around it. So here we are walking. And when each step I take, I'm going to get closer and closer to that line. Well, at each place, so right now, let's say I'm standing right here, right? It looks like that the height I'm standing at is maybe at about 3. And then I take another step forward. And I get a little closer to that line. It looks like maybe now my height's 3 1/4. And we keep walking. And it looks like now my height's maybe 3 1/2. We keep walking and walking. And it looks like each time my height kind of gets closer and closer to 4. Alright. But when we talk about being around a point, we're not just talking about left of it, we're talking all the way around. So I also want to know what happens if I stood on the other side and walked towards that line. Okay? So each step is going to be at a point. So it looks like maybe my height's around 5. I take another step, and it gets more like 5.8 or 4.8. Take another step, and it looks like maybe it's 4 1/2. Another step, 4 1/4. And each step is getting closer and closer to that line. My height seems to be getting closer and closer to 4. So how do we write this, or how do we interpret all of this? So we were looking at the function x squared, and right now we're talking about a limit. Well, typically for limits, the shorthand is we'll write LIM. So this means we're talking about the limit of x squared. But we also need to indicate what point we're looking around. That's really important. So to do that, we write x, because if we look here, it was x, an x value we're getting looking around. And the value we're looking around is 2. So the x arrow 2 tells you that we're looking around 2. Now, what's the answer for this going to be? Well, the answer is what it seems like we're heading towards as we walk closer and closer to this point. and it looked like we were getting closer and closer to a height of 4, so we'd say that the limit equals 4. Now you may be looking at this and thinking, well gosh, that was the same as the point. Well, a lot of functions do behave really nicely, and the point, and when you look around the point, they behave the same way. But sometimes they behave very differently, and that's one of the things that makes limits so helpful. So in our next example, we're going to look at another function which doesn't behave quite as nicely.